Hey everyone, I hope you're doing well today. In this video, let's go over 22 different practice problems on solving one-step equations. And for a bonus at the end, I'll go over 9 practice problems with multi-step equations. So for this first example, let's imagine we have some sort of scale here. So here we have a scale, and it's going to be balanced in the middle on that triangle. And on the left side, let's go ahead and balance some stuff on this tray here, and on the right side, we'll balance some stuff on this one over here. So on the left side, let's go ahead and say that we have some sort of 23-pound weight. Let's go ahead and put that over on the left side. And let's say we have another weight, but this one's going to be 7 pounds, okay? On the right side of the equation, let's say that we have a weight that's going to be y pounds. Let's say we don't know what it is. And we have another weight that's going to be 12 pounds. So we have these 2 different items on the right side as well. So in order for this scale to be balanced, the question is how heavy does the y weight have to be, okay? And so we can write an equation to solve this. So if it's perfectly balanced, we know that 23 pounds plus the 7 pounds on the left side must equal the y pounds plus the 12 pounds along the right side, right? So if the scale's balanced, then both sides must be equal. Now, on the left side of the equation, what we can do is we can go ahead and combine these because this is just a numerical expression, and that works out 23 plus 7 is going to be 30. So we'll have 30 is equal to y plus 12. And if we know that, 30 is equal to y plus 12, then we must be able to rewrite this and say that y is equal to 30 minus 12, right? And 30 minus 12 is going to be 18, so we know y has to be 18 pounds for this to be true. So that would be the answer for this first problem. Now, if you wanted to solve it a slightly different way, you totally could have. If you take this step right over here and then you say, oh, okay, we have 30 is equal to y plus 12. Another way to go about this is saying, okay, and to get y alone here, we can take away 12 from the right side and take away 12 from the left side as well. And if we do that on both sides of the equation, on the left side, 30 minus 12 is going to be 18. So we know 18 is equal to y, or we can turn it around and say y is equal to 18, just like what we kind of had before. Same answer. Okay, so there's number 1. For number 2, let's go ahead and try solving this equation where we have g minus 8 is equal to 25. And so one way we can do this is if we know that g take away 8 is equal to 25, then we should be able to rearrange this equation and say 25 plus 8 is going to be equal to g. And 25 plus 8 is equal to 33, so we can say 33 is equal to g, or turn it around and say that g is equal to 33. There's our answer. Okay. So while that's one way of solving this equation, just by rearranging, here's a second way to go about it. So if we have this original equation, go over here, I'm just copying it down. Another thing we could do here is we could add 8 to the left side of the equation and add 8 to the right side of the equation. And if we go ahead and do that, then those 8s are going to cancel out, so we're just going to get g is equal to 33. So that also works out here. For number 3, let's try solving this equation where we have 25 plus y is equal to 42. Okay, so by rearranging this, if we know 25 plus y is equal to 42, that must mean that 42 take away 25 must equal y. If that's true, we can go ahead and subtract here 42 minus the 25. That's going to be, I think, 17? So we can say 17 is equal to y, and turn that around and say y is equal to 17. Okay, so that would be the answer to this equation. And if you wanted to go ahead and solve it the other way where we go ahead and add or subtract both sides of the equation, let me just copy down the original problem here. 25 plus y is equal to 42. And if you want to solve this equation, you can take away 25 from the left side and then take away 25 from the right side. If we do that to both sides of the equation here, those 25s will become 0 and you get y is equal to whatever 42 minus 25 is, and that is also 17. Okay? So there's 3 practice problems, and let's kind of keep on going and try some more. For a fourth example, let's try solving this equation where we have r plus 82 is equal to 97. So let's try solving this equation. One way to go about this is we can rearrange this. So if we know r plus 82 is equal to 97, that must mean that 97 minus 82 is equal to r. And so what is 97 minus 82? I think that's going to be 15. So we can say 15 is equal to r, or turn this around and say r is equal to 15. That would be our solution here. Okay. Going about it in a slightly different way, we could also take this original equation, say r plus 82 is equal to 97, And to solve this, we can also subtract 82 on both sides of the equation to solve, right? So go ahead and subtract. Those 82s will become 0, and so r is equal to whatever 97 minus 82 is, and that's 15. So that works out. For number 5, let's go ahead and try solving this equation where we have 30 is equal to m minus 18. And to rearrange this, if we know that 30 is equal to m minus 18, then we should be able to say that m is going to be equal to 18 plus 30. Okay, so that's if we rearrange it a bit here. And if we combine 18 and 30 together, we can say that m is equal to 48. That would be our solution. Okay, if you want to go about this a slightly different way, we can go ahead and say, okay, we have this 30 is equal to m minus 18. And to go about this, we're going to have to get this minus 18 over to the other side. We can do that by adding 18 to both sides of the equation. And so on the left side, 30 plus 18 is going to be 48. And on the right side, those 18s go away and become 0. So we have 48 is equal to m, or m is equal to 48. So we get the same answer either way. All right, for number 6, let's try this equation. We have a minus 51, and that's equal to 12. Okay, so doing some rearranging here, we can go ahead and say if we know a minus 51 is equal to 12, that must mean that 12 plus 51 must be equal to a. Okay, if we combine 12 and 51 together, we can say that that is 63, right? 63 is equal to a, or turn it around and say a is equal to 63. Okay, that's one way of finding out the solution. And if we want to use the other method, we can go ahead and say, okay, we have this a minus 51 is equal to 12. And so if we want a alone, we can go ahead and add 51 to the left side and add 51 to the right side. And if we do that, we're going to get a is equal to 63. So we get the same thing either way. All right, for number 7, let's take a look at the equation where we have y minus 11 is equal to 52. And so we want to think to ourselves, how would we solve this problem or solve this equation for y, right? And so we either have to think to ourselves, okay, we're either going to add or we're going to subtract to solve this equation. So, well, how could you rearrange this? Well, instead of saying y minus 11 is 52, couldn't we say that 52 plus 11 is equal to y, right? To solve this, 52 plus 11 gets us our answer. So wouldn't y just be equal to 63? Right? So it's kind of interesting here, right? Because in order to solve this problem that has this clear subtraction sign in the problem, right? This minus sign right over here, how do we go ahead and solve it? We solve it by using addition here. So do we need to use addition or subtraction to solve this type of problem? We need to say that we need to use addition to solve this type of problem. Okay, so since it had subtraction, we need to use addition. That would be the correct operation to use here. And if you were going ahead and solving this equation by doing an operation to both sides of the equation, what you would do is you would end up adding 11 and adding 11 to both sides of the equation. So that minus 11 and plus 11 cancels out and you get y is equal to 63. So just like we said a moment ago, we end up using addition to solve this equation. All right, so we have 7 problems down. Let's keep on rolling. Let's try number 8. All right, so for number 8, let's say that we have some sort of polygon here. So I'm going to go ahead and draw a polygon. So we're going to have a 90-degree angle right over here. Let's draw an angle coming out over here. Let's say this is going to be 135 degrees. And then let's kind of connect this. We'll keep it a 4-sided shape here. We'll call this 75 degrees. And let's call this last side, or last angle rather, angle A. And we'll call this corner vertex A, or the corner of it, okay? So we're gonna try to find out this angle measure located right over here. We wanna see like how many degrees is this last angle measure. So if you're not aware, for quadrilaterals or for 4-sided shapes, we always know that the angles, or the 4 angles, always add up to 360 degrees for these obtuse or convex quadrilaterals. So all the corners are going outward. So we have 360 is equal to angle A. Okay, we have A, and we're going to add on the other ones. That's going to be plus 90, plus this 135, and then plus this 75. So all 4 of these angles have to add up to 360. And we need to find out what the last one is. Okay, so what we can do is we can go ahead and add these 3 angles that we do already know on this right side here. So let me think here, 90 plus 135, I think that's going to be 225. and 225 plus 75 is going to be 300. So we know that on the right side, if we combine our constants, they're like terms with each other, 360 is equal to a plus 300 degrees. Okay, and so if we want to go ahead and solve this equation, something plus 300 equals 360. And I think you might know what it is maybe off the top of your head, but I'm going to go ahead and subtract 300 from both sides. I know you could rearrange it also, but I like kind of solving them this way in general. And so we know 60 degrees has to be the measure of angle A. And I like turning it around, just like writing my variables on the left, but it's totally okay if you leave it like that. So for this to be a quadrilateral, then this last angle measure of A has to equal 60 degrees. For question 9, let's check out this equation where we have 8x minus 1. Let's set that equal to 3x plus 4. Okay, so we have this lovely equation right here. It's a little bit more complicated than the other ones, but the x on the left is the same as the x on the right. And so we have a few different possibilities here. So my question here is going to be, okay, let's say we have a few different values for x to try out. Let's say x could be 0 or 1 or 2 or 3. Okay, so it could be one of these 4 numbers. And so the question is which one of these is true? Only one of them can be the actual answer here. So we can go ahead and substitute each of these to try. So I'll start with 0, and we're going to go until we find one of them. So we have 8x. So what does 8x mean? That means 8 times x. So let's say if x is 0. So 8 times 0 minus 1 is equal to 3 times 0, and then plus 4. Let's see if this works out. On the left side, if we do 8 times 0, that's going to be 0, and then 0 minus 1, that's going to equal negative 1. And on the right side, we have 3 times 0, which is 0 plus 4, and that's equal to 4. Negative 1 doesn't equal 4, right? That doesn't make sense, so we can go ahead and say that's not true. So we know right away that this first one does not work. So I'm going to go ahead and cross out. That's not our answer. Let's try the problem again now. Let's say, okay, now x is 1. So let's say 8 times 1, and then minus the 1. Let's see if that's equal to 3 times the 1, and then add 4. All right, so let's see. 8 times 1 on the left is going to be 8, and then 8 minus 1 is going to be 7. So we have 7 on the left side. On the right, we have 3 times 1, which is 3, and then 3 plus 4, that's going to equal 7. Wait, that makes sense. So because this is true, we know that x does have to equal 1 here. So this one's going to be our answer, right? We can go ahead and say x equals 1 for this equation. Okay, so we were given 4 choices, but one of them was the correct answer. X has to equal 1 to make this equation true. Here's problem 10. Okay, let's say we have this solution here of h is equal to 5. My question is going to be, if I give you a few different equations, which one of these equations has this answer? So here's the first equation. For this first one, let's say for choice A, we have the equation 51 minus h is going to be equal to 46. That's going to be one option. A second option here is, let's say 44 plus h is going to be equal to 51. For a third option, let's just say here we have h minus 4 is equal to 5. And then for this last option, let's say option D here, let's say we have 7h is equal to 42. Okay, so let's see, only one of these is going to have the correct answer. Let's see if we can figure out which one it is going to be. If we rearrange this one, right, instead of saying 51 minus h is equal to 46, we should be able to say that 51 minus 46 is equal to h. And so what is 51 minus 46? Oh wait, that's 5. So we know A is the correct answer here. If you were to rearrange these other ones, I'll just show you what they would look like. Instead of saying 44 plus h equals 51, we can say 51 minus 44 is equal to h, but you're going to find out there that h ends up equaling 7. So that's not the right answer, right? So that would be a different value. For this one, if we know h minus 4 equals 5, we should be able to say that 5 plus 4 is equal to h, but then you would find out that h is equal to 9. So that's not true. And for this last one, this one has multiplication in it. So if we know 7 times h is equal to 42, then we should be able to say that 42 divided by 7 is equal to h. So h would have to equal 6. So that's also not true. So I did want to show you why the other three don't work. That helps you understand what you're doing as well a little bit more clearly. So there's 10 practice problems, and let's go ahead and try some more. So for question 11 here, let's say we have this equation of 44 is equal to x plus 39, okay? So we have an equation here, and let's go ahead and see if we can find, if I give you a few different other equations to look at, let's see which ones have the same solution. So for this first one, we're gonna say 33 is equal to 27 plus x, okay? And then another option here, let's say we have x plus 11, let's say that's gonna be equal to 16. For a third option here, let's say that 4 is equal to x minus 4. For a fourth option, let's go ahead and see. We have 24 is equal to x plus 19. And then let's do a fourth option here, or a fifth option rather. Let's say we have 26 and say that's equal to x plus 21. Okay, so we're going to see which one of these answer choices has the same answer as this original one that we're given. So if we know this original equation says 44 is equal to x plus 39, I think we can go ahead and rearrange this and say that 44 minus 39 is equal to x, right? And so if that's the case, then what's 44 minus 39? I think that's going to be 5. So x equals 5 should be the answer to this equation. So we're trying to figure out which of these other answers or other equations does work out for us. Okay, so we have 5 for the correct answer for the original one. And so let's say for this next answer choice, let's look at this one. Let's say x is 5. Well, what's 27 plus 5? Well, 27 plus 5, I think that's 33, right? Yeah, it's 33, so we know this one does work. Now let's go ahead and plug in 5 for this equation for x here. So let's say, what is this 5 plus 11, right? If x is 5, we'll plug it in. So 5 plus 11, is that going to be 16? I think so, right? 5 plus 11 does equal 16. For this next one here, let's go ahead and plug in 5 for x again. So let's go ahead and do x minus 4, or 5 minus 4, that's equal to 1. And so 1 does not equal 4, so that's not going to work. Okay, I'll put an x on the side here, it does not work. For this fourth one, let's say x is equal to 5. So let's go ahead and plug that in. If we say x is 5, then what's 5 plus 19? 5 plus 19, that's 24. So that one should work okay. And for this last one, let's say x is 5. So it's going to say x plus 21, or 5 plus 21, right? 5 plus 21, that's going to be 26. Oh, that's perfect. That does work out. So 4 of these equations have the same answer of x equals 5. All right, for question 12, let's take a look at some different types of equations. Let's say we have 81 is equal to m over 9, or m divided by 9. That's what this is really saying. So we're saying something m divided by 9, that something divided by 9 is equal to 81. So if you want to rearrange this, we can go ahead and say that 81 times 9 is equal to m, right? So that would be using the inverse operation. So if we think about what is 81 times 9, I think that's 729. So we can say 729 is equal to m, and we can turn that around and say m is equal to 729. Okay, so that's one way of solving this equation. Another way is, okay, let's try to just use where we do the same thing to both sides of the equation. So if we have 81 is equal to m over 9, or m divided by 9, what's the inverse of dividing by 9? It's going to be multiplying by 9. All right, that's the opposite operation. So on the left side, 81 times 9 is going to be 729. And on the right side, the 9s are going to cross cancel with each other, so we just get m. So m does equal 729. For 13, we have another fraction, but let's just go ahead and write it using a division sign here. So again, division signs and fraction bars are the same thing. They mean the same operation here. So if we have h divided by 3 is equal to 12, we should be able to rearrange this and say that h is going to be equal to this 12 times 3. All right, that's going to be equal to h. And so 12 times 3, what's that? Is that 36? So we can say 36 is equal to h, or turn around and say h is equal to 36. That would be that solution. Okay, now if you wanted to use those operations where we do the same thing to both sides, if we have something like this where if h divided by 3 is equal to 12, then what's the inverse or opposite operation? Well, if we take the left side and multiply it by 3, and take the right side and multiply it by 3. If you take h and you divide it by 3, but then you times it by 3, you're just going to be left with 1h, or h. And on the right side, 12 times 3 is going to be 36. So this works out just like we got earlier. In terms of how to isolate for each of these problems, for question 12, how to isolate, we ended up multiplying, right? Multiply for this problem. How do we know to multiply? Well, if you see that we have this divided by 9 in the original problem, then to isolate the variable or isolate m, we have to multiply because that's the inverse operation for division. So if you see division, you have to multiply. For number 13, for this problem, what we're going to have to do is we're going to have to multiply again. Multiply, right? That's how you're going to isolate the variable. But in this case, it's going to be h, right, instead of m. So we see this divided by 3. It's the same operation as number 12, but if we see divide by 3, to isolate h, we have to multiply by 3. All right, let's keep on going over some other practice problems. So for question 14, let's say we have 34 is equal to 17b, or 17 times b, right? So if we know 17, if you forgot, make sure you know 17b means 17 times b. And if we want to isolate the variable here, if we know 34 is equal to 17 times b, then we also know here that 34 divided by 17, right? If we have multiplication, we got to use division, is going to be equal to b. And 34 divided by 17 is equal to 2, so 2 equals b. And we can turn around and say that b is equal to 2, right? That would be the solution to this equation, right? Now, if you want to go about it using one of those properties of equality and do something to both sides of the equation, if we have 34 is equal to 17 times b, then in order to get b alone, or to isolate the variable, we have to go ahead and divide both sides by 17. On the left side, 34 divided by 17 is 2. And on the right side, 17 divided by 17 is 1. So we have 1b, or just b. And so b does equal 2 again. All right, so for question 15, we have this equation of t divided by 35 is equal to 42. So if that's true, we should be able to rearrange this and say that 42 times 35 is equal to t. And so what is 42 times 35? Well, 42 times 35, that's a pretty big number. That's going to be 1,470, okay? And that's going to be equal to t. So we can say t is equal to 1,470. That would be our solution here. All right. Now, if you wanted to use one of those properties of equality, we could do that too. So if we know we have t divided by 35, and that's equal to 42, and to solve this, we're going to go ahead and use multiplication by 35. So on the left side, if you take t, right, and you divide it by 35, but then you multiply it by 35, you're going to go back to just being t, or 1t. And on the right side, what's 42 times 35? Well, we just did that. That's going to be 1,470. So either way you do this, you're going to get the same solution for t. All right, for question 16, we have this equation 7s is equal to 245, or 7 times s, right? So one way we can do this is, we know 7s means 7 times s, so if 7 times something equals 245, that must mean that 245 divided by 7 must equal s, right? And so if we go ahead and figure out what's 245 divided by 7, so 245 divided by 7, I think that's going to be 35. So we can say that's going to be 35 is equal to s, and turn around and say s equals 35. That would be the solution here. Okay. Another way to think about this is, okay, if we have 7s is equal to 245, then if this is 7 times s, then to get rid of the 7, we're going to use the inverse and divide both sides by 7. So we're going to end up with s is equal to, what's 245 divided by 7? We know that's going to be 35. For question 17, let's try this. 29 is equal to k divided by 5. And so to try isolating the variable here, if we know k divided by 5 is equal to 29, that must mean that 29 times 5 is equal to k. And so what's 29 times 5? Well, 30 times 5 is 150. So 150 take away a 5. I think we know that's going to be 145, hopefully. So 145 is equal to k. And so we can turn around and say k is equal to 145. There's our solution. Now, if we want to go ahead and use properties of equality, let's go ahead and practice. Again, it's important to feel good about using both. So k divided by 5 is on the right side. So how do we undo the divided by 5? Well, we multiply by 5 on both sides here. So 5 times 29 is going to be 145. And on the right side, if we have k, right, and we divide by 5, but then we multiply by 5, then we're just back to k. So k does equal 145. All right, just a few more to go for these basic types of equations before we get into a couple multi-step examples. So for question 18, let's say that we have a math tutor and they're going to charge the same amount for every tutoring session. So how much do they charge each time they do a tutoring session? Let's say they're going to charge $S. So S is going to be the amount charged, amount per session. So maybe it's $10 per session, maybe it's $50 per session, maybe it's $100 per session, who knows? So what I'm going to tell you here is that after 21 sessions, we know how much this tutor has earned here. So we're going to say there are 21 sessions. Let's go ahead and write that down, 21 sessions. After 21 sessions of tutoring, Colin or this person, whoever you want to call it, is going to be making this $1,575. Okay, that's how much money they're making. So the question is well, how much does this person make, right? So if we know that they charge $21 per session, so we can say $21 per session, so times the number of sessions, that's going to equal 1,575. Okay, so that's going to be the equation that we could write here. That is using multiplication, right? So again, this means 21 times S equals 1,575. If we want to go ahead and solve this to figure out like how many sessions, or sorry, how many dollars that they're charging per session, we can go ahead and divide both sides of the equation by 21. So if we go ahead and take 1,575 and divide it by 21, you're going to notice that, well, on the left side, you just have one S or S, and on the right side, we're going to get 75. So that means they're charging $75 per session. We can go ahead and write it just like that and say it's going to be a total of $75 per session. That would be the answer. So this right here is a multiplication equation. So it has multiplication as the operation. And if you wanted to write a division equation to represent this, we can say the number of amount of money he's charging per session, or the charging per session here, is going to be S is equal to, and that's going to be the total money that they made, which is this much over here, and we're going to divide that by 21. So this equation here would also get you your answer. This is just rewriting the equation, so we're using division as the operation instead. If you were solving this, again, we're still going to get this 75 because 1,575 divided by 21 does equal 75. So keep in mind, we can use two different operation equations to represent the same thing. So this is one of them using multiplication. Here's our second one using division. But in the end, both of them help us find out that they're charging $75 per tutoring session. Here's problem 19. Let's try solving this equation where we have 7,848, and let's say that's going to divide by W, and that'll be equal to 36. Okay, so we have an equation here that has division as the operation, and we need to use some method to go ahead and figure this out. So this is divided by W is equal to 36, so we should be able to say, okay, if the 7,848 divided by W is equal to 36, then I think we should be able to say that this 7,848 divided by 36 should equal W, right? That should work both ways there. So we can go ahead and think about it like that. And this is a pretty big number here. So again, we can solve this one by just isolating the variable. We're just rearranging it just a little bit so that W is alone. So 7,848 divided by 36, I think that's 218. So we say 218 is equal to W. So W is equal to 218 or 218. Okay. So that's how you solve the equation. And so if we want to go ahead and check this, right, we should be able to check this using multiplication because that's the inverse of division. So if we know that W is equal to 218, then we should be able to take this answer of 218, right? And we should be able to say, okay, 218 multiplied by 36 should equal 7,848. That should be true, right? And so if we go ahead and check that, again, you could check this on a calculator, or you can go ahead and just use the standard algorithm here. We take 218 times 36, just to be very thorough here, that's going to be what, 48. Carry the 4, 6 times 1 is 6, plus 4 is 10, carry the 1, 6 times 2 is 12, plus 1 is 13. We need a placeholder here, we're done with those, done with that. 3 times 8 is 24, carry the 2, 3 times 1 is 3, plus 2 is 5, and then 3 times 2 is 6. Then going ahead and adding up these partial products, we have 8, 4, 8, 7. Hey, look at that. That does match what we were looking for. So we solved this problem using by isolation, right? That was the method we kind of used there, or I used rather. And we got 218, and if we know that 7,848 divided by 36 is equal to 218, then we know 218 times 36 should equal 7,848. Let's just try a couple more here. All right, here's question 20. Let's say that we have 46 golf balls in a bag, okay? So 46 of these golf balls in a bag, and we know for some reason that these golf balls have a total of 15,180 dimples. So those are those little indents on the golf balls. So they're not smooth, they have those little dimples in them, okay? The question is how many dimples are going to be on each golf ball? Just one of them. Okay, so how can we go ahead and solve that using an equation? Well, we have 46 golf balls, right? And we're going to go ahead and say each of those golf balls, how many dimples does each of them have? I use D for dimples, okay? And so if we multiply the number of golf balls by the number of dimples, we should get the number of total dimples on all of them, okay? I've never said dimples this many times in such a short period. And so if we know 46 times that is going to be that big number over there, then we should be able to divide both sides by 46 here. So 46 divided by 46 is just going to be 1. And so we can find out the number of dimples on one golf ball. We can say D is equal to, and 15,180 divided by 46 is going to equal 330. So what did we just find out from that? We're saying one golf ball has 330 dimples. That's what we just found out. If you want to go ahead and check this, feel free to go ahead and do that. If we have 330 dimples for every golf ball and multiply that by 46 golf balls, I promise we will get 15,180 total dimples on all the 46 golf balls combined. All right, for question 21 here, let's say that we have a person, let's call him Teddy here. Let's say Teddy is going to be 7 times older than Bella. So we're going to have Teddy here, and then we're going to have Bella. So we have these two lovely people, Teddy and Bella, and Teddy is going to be 7 times older than Bella, okay? And we're also going to know that Teddy is 42 years old. So let's say Teddy is going to be 42. And we know Teddy is, 7 times older than Bella. So we don't know Bella's age, so we're going to use the variable B to represent Bella's age. You can use any variable, that's fine. But we know that 42, Teddy's age, is equal to 7 times whatever Bella's age is. So again, you can write this as 42 is equal to 7b if you want to write it as a coefficient. But how do you find out just the age for Bella? Well, you're going to go ahead and divide both sides by 7, right? 42 divided by 7 is going to be 6, so 6 is equal to Bella. So we know from this that Bella is 6 years old. 6 years old, just like that. So while we did division to solve this problem, we need 42 divided by 7 is 6. If we take Bella's age and multiply it by 7, so 7 times 6, we get 42, which is Teddy's age. So it does work out. All right, here's one last problem for these more basic types of equations. Suppose we have a cheese farmer and they're distributing 672 ounces of cheese every single day. The cheese is then packaged into 16-ounce containers. So let's go ahead and find the number of containers of cheese distributed each day. So I'm going to go ahead and write down some information here. We have 672 ounces of cheese. That's a lot of cheese. It's a lot of cheddar of cheese. Okay. And that's how much per day. And then we have 16-ounce containers. 16-ounce containers. So hopefully you can imagine there's a ton of cheese here, 672 ounces, and they have to be put into these 16-ounce containers. So the question is as well, how much goes into each of these? So we can set up an equation here. So C is going to be, that's the number of containers. Containers, I think I can spell that. So it's 16 ounces per container, so 16 times C, and that's going to be equal to 672, so it's 16C. You don't have to write the dot if you don't want to. Okay, and to solve this, what do we do? Well, we want one container, so we should divide all of that cheese into 16 containers, so we just know what one container, or 1C, is equal to. And so 672 ounces of cheese split into all of these containers is going to be, there should be 42 containers. Okay, so we should say there are 42 containers. Let's see if this makes sense. If we have 42 containers and there's 16 ounces in each one of them, we should be able to multiply 42 times 16. And what's 42 times 16? Oh, that's 672. So that works out nicely for us. All right, so at this point, that is going to be, those are going to be our 22 practice problems dealing with solving these one-step or more like more basic types of equations that just have a couple steps to them, but most of them have one step, right? It's just understanding how they work. I think one or two of them had more than one step, but not too much more difficult. So let's now take a look at some multi-step equations that are a little bit more challenging. So if you're interested in those, stick around. Otherwise, nice job. All right, so like I said earlier, we're going to do 9 of these multi-step equation type problems. So if you're looking for a little bit more of a challenge compared to the ones we were just looking at, then you are in the right place. So let's try this first one. Again, we're going to do 9 of these. So we have 61 is equal to 16 plus 5 times the quantity of t minus 3. Okay, we're going to try to find out the value for t. So these are a little bit more complicated because you have to use some more knowledge. And so the first thing we're going to do is we're going to go ahead and distribute this 5 to both of these terms inside here. So if we distribute 5, we're going to get 61 is equal to 16 plus 5 times 1t is just going to be 5t, and then 5 times this 3, that's going to be minus 15. Okay. On the right side, what we can do is we can go ahead and combine some like terms here. So this 16 minus 15, that's going to equal 1. So we can say 61 is equal to 1 plus 5t. And we need to combine like terms a little bit here. So we're going to go ahead and subtract 1 from both sides of the equation using the subtraction property of equality. 61 minus 1 is 60, so 60 is equal to 5t. And if we want to get a coefficient of 1 here, we got to divide both sides by 5. 60 divided by 5 is going to be 12, so 12 is equal to 1t, or just t. So t is equal to 12. There would be our answer for this first one. For number 2, let's try solving this equation where we have negative 8 times the quantity of this 3x minus 4. And let's say plus 1, and let's say that's equal to 15. Okay, so first things first, let's go ahead and distribute. We want to get this multiplication out of the way. So negative 8 times 3x, that's going to be negative 24x. And then negative 8 times this 4 is going to be negative 32, because it's a minus negative 32. We can write that as plus 32 plus 1 is equal to 15. On the left side, it looks like we have some like terms, this positive 32 and positive 1. So we can say this is negative 24x plus 33. That's going to be equal to 15. Okay. Next, we want to get the x term alone. So we're going to go ahead and subtract the constant. So let's subtract 33 from both sides of the equation. If we go ahead and subtract 33, we'll get negative 24x on the left side, and what's 15 minus 33? That's going to be negative 18. Okay, and then finally it's divide both sides by negative 24 and divide by negative 24. A negative divided by negative is a positive, and we can go ahead and simplify this fraction. 18 over 24, that's going to be 3/4. So you can either say it's equal to 3/4 as a fraction, or you can say like 0.75 or 75 hundredths if you want to write the decimal instead. All right, so there would be our solution there. For problem 3, let's say we have 8c is equal to 14 minus 0.5, and let's multiply that by the quantity of 10c and then plus 2. Okay, so first thing, let's go ahead and distribute. Again, that's kind of the common first thing to do here because it's multiplication. So we're going to multiply before we add or subtract. So we have this 14, and then what's half of 10c? That's 0.5 of 10c, that's going to be 5c. And then half of 2 is going to be a minus 1 here. Again, it's a negative 0.5 that's being distributed there. Okay. Then we have this 14 minus 1, those constants. So we're going to have 8c is equal to 14 minus 1 is 13, 13 minus 5c. And then what can we do here? We want to combine our like terms, so we're going to add 5c to both sides of the equation to get all the c's on the same side. So 8c plus 5c, we can add those coefficients to get 13c. So 13c is equal to 13. And then we need to divide by 13, so we get a coefficient of 1. So we get c is equal to 1. For question 4, we have 4z is equal to 28 minus 0.25, and then let's multiply that by 4 minus 16z. Okay, so what we're going to do here is go ahead and distribute this over to here and then distribute this over to here. So we're going to get 4z is equal to 28 minus a quarter of 4 is just 1, and then a quarter of 16 is going to be positive 4 because it's a negative negative, so that's a positive. Okay, we have some like terms here, so it looks like we can do 28 minus 1, that's going to be 27, so we have 4z is equal to 27 plus 4z. And then if we go ahead and take away 4z from the left side and take away 4z from the right side, we can see here that we're going to get 0 is equal to 27. And that's just not true, right? 0 doesn't equal 27. So for this one, we're actually going to say here that there is no solution. So there's no possible way that we could find a value for z that makes this equation true. And that's going to happen sometimes. So it's good to know when it happens, and it's, in this case, when you get two numbers that are just not equal to each other, but that's what we got. So that's an incorrect statement. All right, let's try some word problems now. All right, so for question 5, imagine that your brother bought some fish and an aquarium for $250. So $250 is going to be the total amount of money spent. Okay, so that's going to be on some fish and the aquarium. So for the aquarium, I'm just going to use the letter A here to represent it. The aquarium is going to be $175. That's how much you spent on the aquarium. And then for the fish, each of these fish, let's say the fish were going to be $6.25 each. So we need to be able to set up some sort of equation to figure out the total number of fish that were bought. So, well, let's see here. We know $250 is the total that was spent, and we know that $175 was spent on the aquarium, so that's constant, right? That's just that one price, plus $6.25 per fish. So I'm going to use the F again, so talking about the fish here. So how are we going to go ahead and solve this? Well, we need to get rid of the $175 that we know we spent on just the aquarium. Okay, so we go ahead and subtract that from both sides to see how much was actually spent on the fish. So what's 250 minus 175? That's going to be 75, so 75 is equal to $6.25 per fish. And so what if we just want one fish? We divide by 625 and divide by 625. So $75, if it's $6.25 per fish, 75 divided by 6.25 is going to be 12. That's the number of fish. So we know that you must have bought 12 of these fishies. All right, so that equation there helped us figure out exactly how many fishies were bought. All right, for number 6, we know the sum of 3 numbers is equal to 39. So let's write that down. The sum of these 3 numbers is going to equal 39. Let's say for the first number, so let me label this the first number, we're going to call that x. For the second number, what are we going to call that one? The second number is going to be 5 more than the first number, so we can write that as 5 more than the first number, so that's going to be x plus 5. And for the third number, we're going to say is going to be 2 times the second number. So what's the second number? The second number is x plus 5, so it's 2 times that. So we got to take that whole thing and then multiply it by 2, okay? The question is what are the 3 numbers that we're talking about? So, okay, the first number is going to be x. The second number is going to be x plus 5, so we're going to add that on. Again, we're taking this sum, plus the third number, which is 2 times this x plus 5. And all of this is equal to 39 if we add them up together. First things first, we're going to distribute here, okay? And we're going to have x plus 5 plus 2x plus 10 is equal to 39. And let's see if we can combine some stuff. So we have 1x plus another 1x plus another 2x. That's going to be a total of 4x, right? And then we have this 5 and 10 to make 15. So 4x plus 15 is equal to 39. Well, look at that. It's a 2-step equation. So we can take away 15 and take away 15 from both sides here. And if we do that, we're going to get 4x is equal to 24. And then we can divide both sides by 4 here. And we can find out that x is equal to 6. Okay, so if we know that, then this first number, if x is just the first number, then that's going to be 6. That's going to be the first number. That's our answer. For the second number, x plus 5, so 6 plus 5, that's going to be 11. That's the second number here. And for the third number, x is 6. So what's 6 plus 5 is 11. 11 times 2 is going to be 22. So these are our 3 numbers. If we add 6 plus 11 plus 22 together, we do get 39. So that works. Let's try some more here. For number 7, let's say that the difference of 2 numbers is equal to negative 14. Let's call the first number m. So m take away something, the second number here, that's going to be equal to negative 14. Remember, difference means we are subtracting 2 things. For the second number, let's say that's going to be 4 more than 3 times the first number. So let's kind of just label this. So we have our first number. The first number, that's going to be m, right? And for the second number, what did I just say? The second number was going to be, the second number is 4 more than 3 times the first number. So 4 more than 3 times, well, 3 times it is 3m, and 4 more than it is going to be adding 4 onto it. So we have m up here, and we're taking away this 3m plus 4. This whole thing represents the second number here. And so we need to go ahead and figure out these 2 numbers. So let's go ahead and say, okay, we have m minus the quantity of 3m plus 4. That's the second number. That's equal to negative 14. If we distribute this negative 1 that's invisibly in front of the parentheses, that's going to be m minus 3m minus 4 is equal to negative 14. And if we combine these like terms, we have 1m take away 3m, that's going to be negative 2m minus 4 equals negative 14. And if we go ahead and add 4 and add 4, we're going to get here that negative 2m is equal to negative 10. And then dividing by negative 2 and divide by negative 2, we find out that m is equal to 5. So let's go ahead and say, what is our first number here? Well, for this first one, that is just going to be 5. So m is 5. That's the first number. And for the second number here, 3 times 5 is 15. 15 plus 4 is going to be 19. So what's the difference between 5 and 19? Well, 5 minus 19 is negative 14. So that's the difference. So that works out. All right, so the last couple problems here. Let's go ahead and do a geometry problem. So let's go ahead and say, okay, we have this shape that looks like this, okay, more or less. And let's go ahead and say we have a line going across, kind of like that. So we have a rectangle, and let's go ahead and draw these lines. So let's say, I know it's maybe not perfect, but let's say that these two triangles are congruent to each other. Okay, let's pretend. I know it's not perfect. And let's get some measurements here. So for the first measurement, I'm going to put in here from here to here. Let's call that 5 units going across, and from here to here, let's say that's also 5 units across. I'm going to take on the side here, this is going to be 2x units, and then let's say going down the side over here, let's say that's going to be 3x plus 1 units. Okay, so besides that, I'm going to say that the total area of all the shapes combined, the triangles and the rectangles, is going to be 90 square units. So 90 square units here. So we need to find out the value for x here. So let's go ahead and find out the total area of all the pieces here. So for each triangle, well, one of the triangles, it's base times height divided by 2. So the base is 5. The height is 2x, so base times height divided by 2. But keep in mind that there are 2 of these things. So let's go ahead and multiply this whole thing by 2. And then add on base times height for the rectangle. So the base is going to be 5 plus 5, that's going to be 10. And what's the height? That's going to be 3x plus 1. And this whole thing is equal to 90, right? That's the total area. So these are going to cross cancel here, and then 5 times 2x, that's going to be 10x. And then if we distribute this 10 over to these two terms here, that's going to be 30x plus 10, and that's going to be equal to 90. So what's 10x plus 30x? That's going to be 40x. So 40x plus 10 is going to be equal to 90. Now we can go ahead and take away 10 and take away 10 from both sides of the equation. So we get 40x is equal to 80. And then we can divide by 40 and divide by 40. And we can say finally that x is equal to 2. That would be our answer. All right, so that leaves us with one last problem, and it's going to be another geometry one. All right, so let me just take a moment and draw a figure here. So let's say we have a rectangle in the middle here, and we have, let's say, a congruent triangle on top with another congruent triangle on bottom. So imagine these are identical to each other. I know they're probably not exactly, but close enough. And then let's say that we also have congruent triangles on the sides here. So let's say that's like roughly here and here. Okay, so I'll tell you right over here that this length going from top to bottom, this is going to be 4 units, which means that this is also going to be 4 units. Again, these are identical to each other. And then let's see, what are the heights of these triangles on the side? Well, from here to here, I'm going to say this is going to be 3, which means that the height for this one is also going to be 3. And that's going to match over here as well. So that's going to be 3. And let's say that's 3 as well. So all the heights of these triangles are going to be 3. And what we are also going to be told here is that the base of this rectangle, which is the base of the triangle, let me just label that right here. It's going to be a little bit longer. So it's going to be 2x minus 5, which means that that is going to match over here as well. This is going to be 2x minus 5. So we need to go ahead and say, how can we find out the value for x if we know the total area of this shape is going to be 19 square units, okay? So let's start with the rectangle this time. For the rectangle, let's see. It's going to be, the dimensions are 2x minus 5. That's the base of the rectangle times the height, which is 4. Okay, so that's the rectangle. Plus, I'm going to do these tall, skinny triangles on the top and the bottom. So how do you find the area of those? Well, that's base times height divided by 2. So base is 2x minus 5 times height. So base times height, what's the height? It's 3. And that whole thing divided by 2, right? The only thing is that we have 2 of them. So we can take this whole thing and then multiply it by 2, okay? And then after that, we have to do those triangles that are on the side. So the base is going to be what, 4? I think 4 is the base. So it's 4, and the height is going to be 3. So it's 4 times 3 divided by 2. But again, we have 2 of those triangles, so we have to multiply that by 2. Okay. Hopefully you see that, like, if we divide by 2 and times 2, those will cancel out. And if we divide by 2 and times 2, those will also cancel out. Then if we distribute this here to both of these, that's going to be 8x minus 20 plus, and if we distribute here, 3 times 2x and 3 times minus 5, that's going to be what, 6x minus 15, and then plus, and then we have 4 times 3, which is going to equal 12. Again, this whole thing represents the area, which is 19. So I didn't write it earlier, but I'll write it right now. Okay. Combining like terms, 8x plus 6x, that's going to be 14x. Go ahead and write 14x just like that. And then negative 20 minus 15, that's going to be negative 35. Negative 35 plus 12 is going to be negative 33. So minus 23, I think. 23 is equal to 19. Okay. Next, we're going to go ahead and add 23 and add 23. If we add 23 to both sides here, we'll get 14x is equal to 42, I think. And then dividing both sides by 14, we get x is equal to 3. And there is the answer to this last problem. So hopefully you found this video helpful in going through and solving these different types of problems. So we had 22 that were more about one-step equations, and then we had 9 problems that were a little bit more challenging, dealing with multi-step problems and applications for geometry, and some word problems that were a little bit more complex. So hopefully you found it helpful, and as always, keep up the great work. I'll see you in the next one.